Okay, the lighting in my garage is horrible. I've got thousands of watts aimed in various directions. So I'm not doing this just to be cool. We're just going to do a little experiment here for clarity. Okay. Now, the experiments in my last video, hydrothermic engine, disclosed the fact that with a temperature change of 31 Celsius, we achieved 135 millimeters of movement in a 4 millimeter diameter tube. I'm not quite done with this drawing yet. I'll get to that later. And the pressure that we got, I haven't done the math yet. I'm going to do the math. I'm sorry for being incomplete here. It's just this stuff takes a lot of time. All right. And basically, we probably got about 2,500 psi's out of that test if the gauge wouldn't have completely exploded. You can get a lot of pressure out of expanding oil. So I do have a 4,000 psi gauge on an oxygen tank here that I'm going to try. See if I can tear that up. I'm pretty sure that'll handle the situation. But anyway, I've built a new expander here, and I wanted to, it's not done, it's in the construction phase. Basically, I'm going to solder this all together with these protruding this way. And then I'm going to chop them off to length, almost flush. If I had them cut off flush already and went to solder them, you have the problem of clogging up your holes. Then you got to re-drill them out and all that. So I think it'd be easier just to solder them this way and then chop them off with a angle grinder. And then caps are going to go on top of this that are also chopped off. I'm going to chop these down so that it will slide over the end, and then just a single connection will be made here. This chamber will be filled with oil, and these are this is the check valve T. I've been having some serious problems with my check valves. I had to put this one together. I need to just get online and buy some good parts. This retarded thing here, you couldn't twist it on without cutting a special notch, like a slot, a key slot in the flute itself. So I don't know how robust this is. I don't know how well this is going to work. This is probably not rated over 200 psi in my opinion. It's plastic. So there's some problems there. But that's all I could get at Lowe's or Menards, wherever I went that day. I went to both places probably. So if this doesn't work well, or actually if it does work well, I'm going to get online and buy some expensive stuff. I figure I'm going to build this first out of junk. And if I get good results, then it'd be worthy of putting more money into it. So just to catalog the size of this thing, the expander chamber itself is about 30 centimeters. And you probably can't read that. That's about 28 millimeters. So you're looking at, this is type L copper pipe. I can't remember how thick that is. We've got a piece over here. Let's see. And that is about 1.5 millimeters, 1.6 millimeters in thickness. I need to find out what the pressure rating for this pipe is. If you know, leave it in the comment section. But anyway, one valve will be stuck in the T in this direction, and the other will be stuck in this direction. So basically I'm going to turn this thing into a pump. And I intend to pump cold water into it to cool it off. And it's going to be set up like this. Cold water will get pumped into it. And then the heating cycle will consist of a blast of steam that will almost instantly shoot the water out of this thing into a reservoir. And I think that'd be the quickest way to discharge the cooling water. And steam has such incredible heating capacity. I don't know if you've ever done any of the thermodynamic formulas on steam, but steam has an incredible amount of energy in it. And it's insane. When you see the math, it's eye-popping. It's like 50,000 calories to turn 100 grams of water into steam versus I think it's like 1,000 or something to melt the ice, melt it into ice, or melt the ice into water. I can't talk today, but you get the point. And the diameter of my cooling tubes are, it said something like 930 seconds, but I like millimeters. See what I mean by the lighting? 4.64 millimeter tubes, and I believe there's 9 of those. So I'm going to see what the performance of this rig is. I've got some valves that I eventually are going to hook up to servos, but before I can calibrate those servos, I have to run this device manually to see what its operation parameters are. I need to see how long it takes to cool it off, basically. I'm pretty sure the steam's going to heat it up almost instantly, because even with the torch, we've seen a volume increase nearly instantaneous. I think cooling it down is what takes the most time. So if it takes 3 seconds to cool it down, then I'll know to program my Arduino to have our servo rotated on the on section for the valve for 3 seconds. Then it'll go back to heating, and so forth. So I got to run this manually first. I just wanted to get a video of what this thing looks like and catalog the progress, because it makes it easier for me. I can consult the video later on when I'm doing this, because if any of this stuff ever does end up being worth anything, you've got to have a stitch-bound book with it documented inside of it. So I'm at about $225 into this. But that includes this test rig over here. So hopefully this isn't a complete waste of money. I'd like to see maybe 6 of these turned into a high-powered hydraulic pump. If you had 2 water pumps, or just 1 water pump and 1 steam generator, I think that an extremely large amount of energy could be harnessed out of steam. Probably more than a piston engine, because in reality this thing can be converted to use far lower heats than steam. I just want to run it on steam to get its full potential first. I think it'd be more exciting to see what it can do when configured at optimum formats, rather than have it run, you know, on just hot water. It ain't going to be too exciting to see what this thing does on hot water. I'd rather see steam blast through it and get 2,000 psi and burst pipes and break stuff that's got to be fixed. Because if it doesn't tear itself up, it's really not worth the time. It has to be that powerful that it's literally hard to build, in my opinion. So there you have it.